Hello everyone! Chapter 1, Learning Targets 1 and 2. Oh my goodness, this is Miss Oshier.
And Miss LaHart.
And here we go.
Ooh.
So you're going to be able to determine and explain whether or not a function is a polynomial based on its equation, and determine its end behavior based on the equation.
Whoa.
That sounds exciting.
Look at us go.
Okay, so here's the fancy math definition of a polynomial. It's a non-negative integer, etc. It's a real number. All of this means the exponents cannot be fractions and they can't be negative.
Whoa.
So all that scary stuff just means this.
So in order to be a polynomial, all of your exponents have to be positive and not fractions.
That's the gist. So determine whether this is a polynomial. If it is, identify the degree, leading coefficient, and constant coefficient. So is this a polynomial?
Whoa.
I see exponents there. Are those exponents negative?
Nope.
Are they fractions?
Nope.
So is this a polynomial?
Yes.
Yes! Look at us
Yay.
go! Alright, degree. Degree comes from the highest degree when it's in standard form. That's important, standard form. Remember, standard form is when the variables go from greatest to least exponent order.
Sometimes they might trip you up and not put it in standard form, so you got to look out for that.
Pay attention.
So the highest degree is 3.
Perfect. Leading coefficient, that's the number that comes in front of the variable with the highest degree. So that would be, in this case, oh, look at that, radical 2. So reminder, it comes from the number in front of the variable with the highest exponent.
Constant coefficient is a number. A constant is a number, and a number is pretty constant. It can't really change.
Boom.
So in this equation, the negative 1/6, although it's a fraction, it still is a constant because it still is a number.
Number. Basically the one that doesn't have a variable.
Yeah, that too. Boom.
Okay. So let's do it again. Is this a polynomial function? Well, let me take a peek at all of my variables. 5 is positive, 2 is positive. Oh, what's this being raised to? 1, right? Because when I can't see it, it's a 1.
But I could write this as 7x to the negative 1.
Oh, that's right. Technically, that's a negative exponent.
So no, it's not a negative.
No, so we can't answer anything else.
You would just write like NA, not applicable.
Right. You would explain why. You would say no because there's a negative exponent. Boom.
Ooh.
Is this a polynomial function?
Tricky, tricky.
Okay, let me find my variable. Oh, I don't have one.
But
do I? Let's think here. The degree is 0 because actually I thought I had it in here. Maybe I don't. Oh,
Nope.
Okay. I thought I had the little flashy stuff coming up. It is a polynomial because technically there's an x to the 0 next to this. Because what's anything raised to the 0 power?
1.
1. So I could write x to the 0 all day long next to it. So it's a degree of 0. So whenever you have just a constant, that's going to be both your leading coefficient and your constant coefficient.
That's probably the only tricky way we can get you.
Tricky. All right. General graphs of polynomial functions.
Oh, you can't see me, but I'm dancing.
She's dancing. It looks real good. All right. So let's see here. Let's focus on the even degree functions. Not even functions, but even degree functions. They start and end in the same location. Notice how they both are starting up and ending up.
They're pretty.
The odd functions, the odd degree functions, excuse me. Odd degree, they start and end in different locations.
They're more dance-like.
They are more
Trust me,
dance-like.
we'll show you the dances in class.
They're really nice. Okay, so let's talk about this. If the degree of the polynomial is even and the leading coefficient is positive, it's going to be a smiley face because you're going to end into the same direction, and it's positive, so you're going to end up. So it's a happy.
Now, if it's an even with a negative for a leading coefficient, you're going to have yourself a frowny, which means they're both going to end down.
An odd degree with a leading coefficient positive, it's going to start down and end up because it's positive, so it ends up.
However, if you have yourself a negative in front, that means that it starts up, but then it ends down because it's sad.
It's sad. All right, so basically, even degree functions start and end in the same direction. Odd degree functions start and end in the opposite direction. So use the leading coefficient and degree to describe the end behavior. So if I'm looking at this right now, I see that I have an even degree, and I see that my leading coefficient is positive. If you're like, there isn't a number there, Miss Oshier, you're seeing things, I'm all like, there's an invisible one.
And it's a positive invisible one.
Okay, so that means it's going to be upward because it's positive. And it would have started and ended upward. Like I could draw just a quick sketch. It would be like a U.
All right, this one. Ooh, it is not in standard form. How tricky, but I know. Oh, look it. I'm searching for it. Oh, there it is.
Good job, Miss
the
LaHart.
highest exponent power, which means that this guy is an odd degree, and it has a -2 for a leading coefficient. So therefore, I know that it's going to start up and end down.
Boom.
And then an
Remember,
opposite.
we're describing the end behavior. That throws people off sometimes.
Ooh, this is a little bit different. But, so what happens if we give you a picture of a graph? Can you tell us the pieces then?
Okay, so is it positive or negative? Well, it's ending up. So that tells me, whoop, with my magnifying glass, that it's positive. Now, is it even or odd? Well, let me see where it started. It started in the same direction. So that means it's an even degree. Look at
Boy.
it go.
Ooh, I got this one. All right, so it ends down, so I know that that's a negative coefficient. And then I know that they end in opposite directions, so I know that that means it's an odd guy.
Look at that. That's it, everybody. We will see you in class.
First video down.
Woo!